T5, applying the trigonometric ratios. Sometimes you're going to get the instruction to solve a triangle, but that just means to find all the lengths of the sides and all the angle measures of all the angles. So just a few things to remember. Even though we're using SOHCAHTOA, so you can, or right angle trig, SOHCAHTOA as we sometimes call it. Let's write this on the top of our page so we can refer to it. SOHCAHTOA. Of course, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Other things that we can use though is all angles in a triangle add to 180 degrees. Okay, so we don't have to use trigonometric ratios all the time. We can to find angles we can use what we know of our triangles and all the angles in it. And the other thing that we can use is Pythagorean theorem. So c squared, so our hypotenuse is a squared, a side length plus b squared. Sweet. So let's solve the first one right here. Solve triangle XYZ, and this is what we've been given. So you know that this one right here is our right angle triangle. So this for sure is our hypotenuse. Let's go from the angle of y. So let's figure out what angle y is. I know that this is my opposite and this is my adjacent. So when I'm looking at my trigonometric ratios, I have opposite and adjacent. Okay, so I'm just going to highlight every single time we have an opposite and adjacent, but the one that uses both opposite and adjacent is tan. So let's use tangent of y to solve for y. So tan, that's not very helpful. Okay, tan of y is going to be our opposite, which is 6 over 10. To solve for y, we go tan inverse of 6 over 10. Let's figure out what that is by using our calculator. So inverse tan of 6 divided by 10 equals, oh man, I did it again, I forgot, degrees. Let's do this again. Inverse tan of 6 divided by 10 is, there you go, 30.96 degrees. So 30.96 degrees. So to find to find x, what we could do, we could, use the tan of x to solve it, but let's just use what we know of triangles. So x is just going to be 180 degrees minus that 90 degrees that we have right here, minus our 30.96 degrees, because that's what we calculated this one out to be, 30.96 degrees. Okay, so when we do that, 180 minus 90 minus 30.96, we get 59.04. 59.04 degrees. So that's what our x is. 59.04 degrees. The only thing that's left to solve is the hypotenuse. So why don't we just use Pythagorean theorem for that? Because that is maybe even a little bit easier than using other things. Because we've calculated both of these angles, but we can find the hypotenuse just by using our given information. So you're going to say hypotenuse squared, or c squared, but we'll call it hypotenuse squared this time, is 6 squared plus 10 squared. H squared is 36 plus 100. H squared is going to be 130. Ooh, that's a weird 3. 136. We're going to take the square root of both sides. So we're going to find the square root of 136. and we get 11.66. 11.66, and we'll use the centimeters because that's what's been given. Awesome. So we have found all three angles and we have solved all three sides. That means that the triangle has been solved. All right, let's do this one. This one feels like it doesn't have a ton of information, but just remember this F is a right angle here. And what I want to do is I want to call this by the line segment name. So this right here is going to be our DE. This guy right here is going to be our EF. And this right here is our angle D. Okay, so first things first, angle D is going to be real easy to find, and maybe it'll be useful. So let's find it right away. So angle D is going to be 180 minus 90 degrees, because we have that right angle, minus 25. And we get 65 degrees. All right. So let's go from the angle that we started with right here, and we're going to call this our opposite. We're going to call this our hypotenuse, and we're going to call this our adjacent. So we have solved all the angles in this triangle. So what we're going to do now is we're going to solve for our DE and for our EF. First of all, let's solve for our hypotenuse, for our DE. Okay, so in terms of SOHCAHTOA, we would be given our opposite, and we would use our hypotenuse. Okay, so if I go back up here and I highlight the opposite and hypotenuse, oh, it's not, okay. Well, it's not really wanting to do what I wanted to do, but that's okay. Let's just skip right to it. Opposite and hypotenuse is going to be our sine. I was trying to do what I was doing before. So we have our opposite and hypotenuse, so we say sine of 25 over 1 is going to be our opposite, which is 5, over our hypotenuse, which we're going to calculate, which we're going to call our DE, our line segment naming. And now we're going to cross multiply. DE times sine of 25 is equal to 5. We're going to divide both sides by sine of 25. This cancels. So then we're left with DE equals 5 over sine of 25. So 5 divided by the sine of 25 equals 11.83. So DE is 11.83 centimeters. Okay, that kind of makes sense because it's longer than the 5, the opposite, which makes sense because the hypotenuse is the longest side. All right. So I'm just going to change colors here, and we're still going to use this as we're still going to use 25 as our reference angle, but we're going to use adjacent and opposite. So adjacent and opposite, we'll be using tan, because tan is opposite over adjacent. So we're going to say tan of 25 over 1 is opposite, which is 5, divided by adjacent, which we're calling EF. So that means that EF times the tan of 25 equals 5. Divide both sides by the tan of 25. Sorry, I'm losing room here. I don't want to squish too much. So we're left with EF equals 5 divided by the tan of 25. I'm going to use my calculator here. 5 divided by the tan of 25. I get 10.72. EF equals 10.72, which makes sense because 65 is a bigger angle than 25. Okay, so that 65 will have the side that's opposite a little bit like bigger than an angle side that's opposite an angle of 25. Fantastic. So we just solved it. We know all the angles in the triangle and we know all the sides. Okay, this is a little bit tricky, and I'm going to draw triangles multiple times to try to explain how to do this here, okay? So, a small table has a shape of a regular octagon. The distance from one vertex to the opposite vertex measured through the center of the table is approximately 30 centimeters. There is a strip of wood veneer around the edge of the table. What is the length of the veneer to the mere centimeter? So what it's asking us to do is it's asking us to calculate what's the perimeter? What are all of these sides? So now what we need to do is we need to get really creative with how we draw our lines. So if this whole thing right here is 30 centimeters, that means from the center to one of the vertices is going to be 15 centimeters. I can do that anywhere. I can also draw one right here, and I know that that is also going to be 15 centimeters. In fact, I can do this 8 times. I can make this into a shape of 8 triangles that go together. So then, if I can do that, I can figure out what this whole angle right here is. Because in a whole rotation from here to here, that is 360 degrees. So I'm going to take my 360 degrees and I'm going to divide it into 8 equal portions. When I do that, I get 45 degrees. So that means that this one right here is 45 degrees. And we know that it's an isosceles triangle, okay? They're the same, okay? And each of the sides are 15 centimeters. I am going to just draw this out just a little bit bigger, okay? So I'm going to go like this, and like this, and like this. I know that this one right here is 45. I know that this right here is 15 centimeters. And this one right here is also 15 centimeters. All right. So this right here, okay, I'm gonna try to highlight again. There we go. Okay, this right here matches with this side right here. So if I figure out what the length of this bottom piece is, and I multiply it by 1, 2, 3, 4, 5, 6, 7, 8, I'm gonna know what the perimeter is. So I need to draw one more line, okay? We're going to make it into a little spicy meatball here. We are going to draw a line down here, and this is a perpendicular bisector. So what that means is that it's split this angle precisely in half. So this right here is going to be 22.5 degrees, just as this is going to be 22.5 degrees. Okay, so what I can do is I can use this right here, this angle right here. Here's my, and I'm just going to highlight it one more time in yellow. I'm going to take this triangle right here, and I'm going to find the length right here. I'm going to call this X. So in terms of opposite, adjacent, and hypotenuse, this one right here is going to be our hypotenuse. This is our opposite. And this right here is our beside side. This is our adjacent. So we need to have the X and we have the H, so we're going to use sine. So the sine of 22 the decimal didn't turn out very good there. 22.5 over 1 is opposite, which we called X, over hypotenuse, which we were given as 15. So let's cross multiply here. We don't have to divide out. X equals 15 times the sine of 22.5. So we can figure out what this X is. So the sine of 22.5, close bracket, times 15 equals 5.74. 5.74. So this right here is going to be 5.74. Okay, so if we wanted to have the full length of the green line right here, which matches up with this right here, what I need to do is I need to say this is 5.74 and also this right here is 5.74. So when we add those two things together, 5.74 times 2, it's going to be 11.48. So this whole thing right here together is going to be 11.48. So that means that this is 11.48. This is 11.48. And so on and so on and so on and so on 8 times. So in order to find the perimeter, what we need to do is we need to take that 11.48 and we need to multiply it by 8 times because we have 8 sides in this octagon. Okay, so 11.48, so work smarter than not harder, times 8 is 91.84. 91.84 centimeters. So that veneer is, the length of that veneer is 91.84 centimeters. Just a heads up, this is a very difficult question. This is something that you would get on something like a hand-in assignment or a homework exercise, but it's not necessarily something that I would put on a final exam or that sort of thing. So if you're really spooked by this, don't worry. Just if you can follow along with it and start getting creative about where you're drawing your lines, that's the most important piece here. Okay, so go ahead and do your homework exercises.